Well, hey everybody. So as we discovered on Monday, I hadn't laid the class out right to account for the fact that next Monday is a holiday. I had to move some things around. In particular, I had to take the content from January 20th, move it to this Wednesday to January 15th, and in particular, what we have on the schedule here is pair programming and introducing the first phase of our project and doing more TDD. This whole explore the first phase of our project is mainly a one-sided communication. It's me telling you a lot of things, so I thought I would pre-record all of that here, and that would allow you to watch it when you can, so you can start on your project one. Actually, it's pretty important that you get started now on project one as you're wrapping up the koans. This will help you just get going in the course. What we'll be doing in class tomorrow is learning about pair programming by watching others do it. We can still talk about the stuff that you see tonight if you have a chance to watch it, but we'll be focusing on a pair programming exercise that I call the operating theater, where everybody has an opportunity to see some people pair programming before they have to do it themselves. So let's dive into it. Let's talk about project one. So as I mentioned on the first day, the programming assignments in this course is a six-phase project, and this is the first one. So the project has a theme of designing an airline application. Here in this first project, you'll be designing and implementing the fundamental classes for it, but every assignment you add a little bit more. So next time it'll be saving the contents of an airline to a file. Then you'll be learning about how to format text nicely so that a human can read it. After that, you'll be saving the contents of the airline to an XML format. Then you'll have a REST API for it. And finally, you'll have an Android application that manages the airline. And every single one of those phases uses the classes that you will create here in Project One. So it's important. It's a good place to start, but it's also a simple place to start. And I'll talk about the details shortly. So it's worth 6 points overall and is due on January 29th. So it's due in a couple of weeks. So please get started now to make sure that you have a good trajectory for not only this project, but for the other projects in the course. So the whole idea of what we're doing here is taking classes that you did not write. So you'll be working with a lot of classes that I wrote, and then doing some command line parsing, kind of what we'll see with the student project. But here you'll be doing it for an airline. So what we'll do here in a little bit, I'll talk about the expectations for the assignment, and then I'll show how you can create the code, the Maven project for this assignment, and then we'll work with the code in there. So I provide you with two abstract classes that are in the EDU PDX CS Joy package. They're called Abstract Airline and Abstract Flight. And what you'll do in the assignment is take these, or one of the things you'll do in this assignment is take those two classes and subclass them and make them concrete. And you'll put those in your package. So there's an airline class that extends abstract airline and a flight class, these are your classes, that extends abstract flight. And because they are concrete classes and not abstract, your classes need to implement all of the methods of a superclass. So airline and flights have some properties associated with them. Every airline has a name, and every airline consists of multiple flights, so 0 or more flights. A flight departs from some source location and leaves at a given departure time, and arrives at a destination location at a given arrival time. So for this first assignment, you'll be modeling all of this data as strings. In later assignments, you'll get to use the local datetime class and things like that. But for right now, let's just start off easy with strings. Each flight also has a number associated with it, which is an integer, an int. There's a couple of methods you can ignore right now, get departure and get arrival. We'll be seeing those in project 3, I believe. Oh yeah, and then yes, again, it has an identifying number that is an int. So you'll be creating the airline class, the flight class, and there's also a project one class, which has the main method that that is the main program. So what does it do? It parses the command line. So these are the arguments that are passed in on the command line. And from that information, and assuming everything's valid, it'll create an airline and add a flight to that airline containing the information specified on the command line. Also, if the dash print option is specified, the main program should print a description of the flight by invoking its toString method, and actually print a description to standard output of that flight by invoking the toString method. So here's the way that the command line interface works for that main class in Project One. The airline project uses an executable jar, like we saw with the student project, meaning that all you need to put on the command line is the following. You say Java to invoke the Java virtual machine, use the -jar option, and then you put a reference to the jar file that's created by Maven. And then following that are some options that are optional and may appear in any order. And then the arguments, which are not optional, or each one of them is required and they appear in a certain order. Those order are the following. First argument is the name of the airline, followed by the flight number, the 3-letter code of the departure airport, the departure time, and that's in the format month, date, year, hour, minute. Notice this is 24-hour time. After the departure time is the destination code, so the 3-letter code of the arrival airport, and then the arrival time, again in that same format. So those all appear after the options. The options that precede those arguments are -print, which will again print the description of a new flight by invoking its toString method and printing it to standard output. And then also something called a -readme, which I'll talk about in a little bit what that's all about. So here are the options and the arguments for the main method. Now note that there's a couple of things about invoking this program on the command line. Something like, well, I guess really this name of the airline might be multi-words. And so then because this is a single command line argument, if you have a multi-word airline name, then you should surround it with double quotes on the command line. However, dates and times are not quoted. Each date and so basically the departure time and the arrival time, each one of these is 3 command line arguments, meaning that they aren't separated by quotes. So for instance, here are some valid dates and times like 3/15/2025, 10:39, and 03/2/2025 at 1:03. As you probably notice, the actual behavior of this program is really quite simple. You create, one object, you add another object to it. Yeah, that's not very interesting. What is interesting about this assignment, and really the goal here, and what you'll ultimately be assessed on, is the command line parsing, right? Making sure that you can handle invalid command line arguments or command line arguments that are missing. I'll talk about some of the common errors that you should be looking out for in just a little bit here. But if you're saying, wow, this seems really interesting, or if you just don't get why we're doing this, well, we're starting this way so that you can figure out a good strategy for command line parsing and just get used to writing some Java code. Lots of footnotes here that I'll let you read. A couple of things though to point out. Note that the only way the user provides input is from the command line arguments. Do not read from a file and do not read from standard input. Over the years, I've had some students, this is like CS 101. It's like, oh, well, if there wasn't something specified on the command line, you should just, enter something in from standard input and, hit return. That's not going to work with my grading scripts. Please don't do that. We don't use standard input in this class. It's, the year 2025. There's, different ways of interacting with software now. Oh, looks like this got cut off. Sorry about that. So, I mentioned error handling. So it's a lot of what you do in this first project, right? Admittedly. So please exit gracefully by printing a nice error message, and don't invoke system.exit. That'll just mess up things like the integration tests, which we'll learn about later. So make sure that you have a nice error message when there's a reasonable error condition that is encountered. Please don't print exceptions and stack traces either. That's not friendly. So for instance, if something's missing from the command line, or you have too much stuff on the command line, or if one of the formats is wrong, right? The day and time is wrong, or the flight number isn't a number, or if the airport code doesn't contain 3 letters, right? It's sort of like common sense parsing like this. And always, if you have any questions, please feel free to reach out to me on Slack about a particular scenario. And what I really encourage you to do is to write a test for that scenario and express what you expect to happen. There it's much easier for me to understand exactly what you're talking about and give you feedback on code than it is for us to necessarily have a conversation about all the potential things that could maybe go wrong. Note also that if you have no command line arguments provided, please provide a helpful message that explains how the program is used. So just don't say something like command line arguments. Print out information about the command line syntax, or if if there are missing command line arguments, please specify what command line argument was missing. So just to reiterate, because what we're dealing with here is, pretty simple, there's really only one test case for the happy path. So most of what the test cases will focus on is providing, invalid input into the program. And this is what we do for Project 1. Don't worry, it'll get more interesting in Project 2. But the whole idea of this project, again, is to get you used to writing some Java code and to, actually in particular, the command line parsing. Okay, I'll talk about submitting the files and everything like that shortly. I think I'll just turn it over now to the repository, to the GitHub repository for creating the project. Oops. So get rid of that little window. I don't need to see myself. I'm gonna say hi. Meeting controls. Oops. The wrong one. And I want to say hide video panel. There we go. Great. Okay. I'm going to say hide floating media controls too. Nice. Okay, so I'm going to SSH back onto the PSU machines. I'm going to go into my checkout and then joy of coding. And there is a create first project script. This works just like the create koans or create student. So this will go off and it will get the Maven archetype for creating the project for the Maven project for Project 1. Download some stuff. Great. And so now we see, good, there is an airline project. So I'm going to add that to Git. And I'm going to commit it here. Again, this is on the PSU machines. You can only run those create scripts on the PSU machines. I'm going to say added Project 1. Well, beginnings. No, add Project 1. Why not? And then I'm going to push that up to GitHub. Right, you've seen this a couple times before, and you've probably figured it all out. I haven't figured out how to type my password correctly, though. Oh, that's right. There were some changes I didn't pull in. I'm going to do that, and it'll hopefully merge everything okay. It might have problems with the pom.xml. Okay, I guess I haven't configured this globally. Not surprised. Funny. I prefer merges. So I'll say global. I wonder why. I wonder if it was a new version of Git installed or something. Yep, it merged in things. That's great. Oops. Nice. I think that seemed to be okay. I don't think there's anything else to push. Oh, maybe there was. Okay. Nice. Now I'm going to go pull over here in my repository on my local machine. Good. Got the airline. So now, okay, I did that. Oh, now I'm going to go back to IntelliJ. I could have pulled the changes from here also. It is let's see here. I think I might need to sync this up. I'm going to say reload all from disk. And oh, yep, it looks like it found the airline project. It's doing its Maven thing and is analyzing that. Yep, it's syncing it. Nice. Okay, now it recognizes as a project, and the way you know it does is that it has it in bold. And so then here are the classes, often main in the main Java. We have several things. We won't need airline XML helper just yet, nor will we need the text dumper and the text parser. Those are there for future projects. For project one, you'll need the airline and the flight. So airline is as following. Airline extends abstract flight, and it takes a flight because that's what you add to the airline. That's what you get from the airline. Each airline has a name. And similarly, I can open up oh, it's even somehow doesn't look for flight, probably because I had it selected. Yep, and here's flight. So out of the box, it returns, okay, it's got some, oh, it looks like it throws some unsupported operation exceptions. That's kind of cool. We can also look for things like the flight test. Yeah, there it is. And there's a unit test that comes with it. Oh yeah, and some of these, you'll need to modify out of the box here. Let's just make sure that this can behavior that's created by the archetype does what I expect. Nice. Okay. Well, actually, I want to look at my. Oh, and there's also the project one class. So I will go back to the project view and I look at the project one class. Want that over here on the left. Close that. Project one is really quite simple. It creates a new flight and then prints missing command line arguments. So just like what we saw with the student project, when we run Maven verify, that will go through and it will build all the phases of the project. It'll compile the source code. It will compile the unit test. It will run the unit test against it. It'll create that executable jar file. Then I'll go through and run the integration tests, which again, we'll talk about integration tests in a little bit. And we will we'll give that a moment or three to finish. Good, that was all successful. And now we've got in the target directory an airline.jar, and we'll run it with java-jar. And we see it prints missing command line arguments, just like we expect here. So everything seems to be working all right. And so then your job is to implement this functionality in project one, do the command line parsing. And if you look at the flight, you can see that there's some, let's see here, like get source and get destination. Those need to be implemented. Right now they throw unsupported operation exceptions. It needs to be a little bit more interesting. Oh, I'm sorry, not get source. Yeah, get source and get destination. Are those really strings? No, those are strings. Those are strings because those are the three. Yeah. Those are the 3-letter codes. Yep. And then you need to also get the departure. You have to also implement the departure string and the arrival string. I guess one more thing that I'll point out. Remember that. Download the sources there. But recall that what the -print option does, it prints out the toString value of a flight. ToString is actually inherited from abstract flight, and it's a final method, so you can't overwrite it. So you have to use this one, which is actually kind of nice. So you inherit the implementation of ToString, but it means that you need to implement all these methods that ToString calls, like get number, get departure string, get arrival string, things like that. I'm pretty sure that's all this is what this is saying here. I'll just scroll through and see if there's anything else. No, this is all looking good. And here again, use Maven verify to run it. And so, yeah, that's your first project. I encourage you to use test-driven development for this project. We'll see in a little bit what the requirements are for for testing it. But yeah, you will need to have unit tests and integration tests such that 75% of your code is covered. Okay, so let's see here. That's everything on the project. Feel free to ask questions about it on Slack. I've got two handouts that I want to talk about. The first one is how to test your projects. So, as we started talking about on Monday, and as you'll hear me reiterate, harp on over and over again, it's really important to have automated tests for your code. And it wasn't always this way though. So, when I first entered the field, it was unit testing had just been introduced like a year or two before, and it was still very sort of bleeding edge, and only a handful of people knew about it, and even fewer people used it. Because at the time we thought, well, it was responsible and appropriate to have one set of people writing the code, and another set of people testing the code, and it should only be tested from the outside, and that there was these are two very different roles. But there were some problems. When there was a problem to be found, there was often a long feedback loop between when the issue was introduced and when the issue was found, and then even longer to when the issue would be fixed. And so then, as a developer, this is a real problem because someone found a bug in your code, and it was months since you've touched that code, so it was really hard for you to get back into the problem. Also, when testing happens long after the fact, it's not always. Oftentimes, there's not clear agreement on what the expected behavior should be, and so you have people, arguing back and forth about, well, how really should it behave, and you've got the person who's testing the code where it's all fresh in their head, and again, if the developer hasn't thought about that code in months, like, well, I made the decision, I don't know why I didn't have to go back and remember a whole bunch of stuff. Again, not so great. Also, when development and testing happen far apart, the development folks say, okay, yep, the code's done, it's all ready. And so there's perception. It's like, okay, great, it's ready to go. And if the testing hasn't started yet, no, it's not, because all the bugs haven't been found yet. And then it somehow becomes the tester's fault that they found the bugs, as opposed to the fact that there's just a problem with the system. So it's much better to have a rapid feedback loop. And then finally, the people that I witnessed this myself early in my career, that the people who tested were somehow like second-class citizens. Like what they did wasn't either important as valuable as writing the code. When actually, I kind of think it's the opposite. It's like, wow, if you find a problem before the customer does, that is super valuable right there. And so then, but because there wasn't good coordination between the developers and the testers, these things took longer to build, and it was much easier to tolerate lower quality work, and our users suffered from it. So, things have changed, in the last 20, 25 years, and changed for the better. So now we have these unit testing frameworks that are really quite easy to use, and because of that, something like testing and development is now feasible, is now possible. And so now it's seen as writing automated tests for your software is just a standard part of developing code. It isn't somebody else's job; it's the job of the developer. Now, there's still lots of great stuff for testers to do. They can focus on things that are higher value and more complex. But unit testing and automated testing is a very important thing. So, what does this mean for you? Well, in this course, every project has it requires you to author two kinds of automated tests: unit tests and integration tests. So unit tests are all about the internal logic of a single unit within the program, like a class or a method, things like that. An integration test, on the other hand, exercises functionality that goes across multiple units. So what we'll see is, right now that our integration tests focus in on the main method, right? And so it tests, both the airline class and the flight class. And as you add more and more capabilities to your program, more code will be exercised by that main method, right? You'll be reading to files. You'll be, formatting the airline so that it's easy to read, things like that. So you have unit tests that focus on each individual class, and then you have an integration test that focuses on the main, which then exercises multiple classes. I wrote a little framework class called Invoke Main Test Case, which lets you test main methods and you can provide the command line arguments, and then you can interrogate what was written to standard input. What was written to standard output and standard error. So then I don't know. I'll put together a separate screencast, or maybe we'll see it in class tomorrow. How you use this, but that's how you can best test your main method. Because remember, the interface to the main program is the command line arguments is what's sent in by the user, and then what's consumed by the user is what's written to standard output and standard error. Now, I had for a couple of years I had merely encouraged students to write unit tests, and some did, but most sort of didn't know how to get started, or said, well, hey, that's all very nice, but come on, I got work to do, I got other classes to take care of. Nope, they feel they got it, written good enough, and so maybe they had like their own own tests on the command line, but they weren't true integration tests or unit tests. So I made the decision to require test coverage for the projects, and so I use this tool called Jacoco for Java code coverage for assessing the code coverage of the tests. So when you run when you run Maven with -p for profile, the greater profile, so -P greater, what it'll do is it will run the tests with code coverage to determine how much of the code was executed by the tests. I'm gonna do that now, actually. So let's see here, Maven -p greater, and I like to do a clean. Just works better if you start from scratch. Doesn't take that much longer. So what this will do again is go through all the build phases. Well, the clean, actually, I may have talked about clean. Clean will go and delete all the artifacts that were created. Basically, this starts over from scratch, because normally, let's say that you haven't made any changes to your source code, it won't bother recompiling anything. Oh, and look, it fails because the code coverage checks weren't matched. And this is the telltale line right here. Instructions covered ratio is 66%, but expected minimum is 75%. And this is true. So when you run with -p greater, it will not only run with code coverage, but it will fail but the verification step will fail if the tests don't cover at least 75% of the code. Now, one of the nice things about Jacoco is that it generates some reports to tell you what code is and is not generated. And I believe it's in this target site, Jacoco. Actually, I probably say it here. There you go. Target site, Jacoco index.html. Nice. It creates this report right here that lets you see by package, how much code. And we're looking at instructions right here. So yep, sure enough, it only got 66% of the instructions. What does this say? Oh yeah, the Miss Branches got most of the branches, but there were some instructions that weren't set. And considering this doesn't do very much out of the box, it's not terribly surprising. But you can drill into this report to then see by class. So for instance, some of these, text parser really isn't being involved. But look, your top 3 right here are the ones that miss the coverage. So here, if we just look at project 1, like here in the main method, you can drill in, you can see that, oh yeah, here, like this method isn't invoked, and here, it never actually gets to the part of printing it out, because I think the only test that executes the main method does so with 0 arguments. So I like, I like the reports here because it really tells you what are the classes and what is the code that wasn't covered by your tests. Similarly for flight, you can see that, oh look, these methods are never invoked at all, and these ones are. That's nice. but these ones aren't. And again, you can drill into the source code and you can see that just aren't invoked. And I guess my thinking here is that for this course to encourage you to write unit tests, to force you to write unit tests, quite frankly, I want to have code coverage, and 75% seems reasonable. I don't want anybody having large swaths of code that isn't tested, but hey, if there's some stuff that you don't have a test for, it'll be all right. 75% has actually worked out pretty well, it seems, over the years. So again, running with -p greater we'll give you those reports. We'll do that code coverage and give you reports. Note that if the tests don't provide sufficient coverage, you can lose up to 1 point on your project grade. Again, so one of my test cases is run it with code coverage and see how it goes. I've got a couple of notes here about what to do when you encounter certain errors in IntelliJ. Sometimes you see this test engine with ID JUnit Jupyter test fail, and that's the case, then just run maven-w clean, or maybe you need to rebuild your project from IntelliJ. Also, please do not invoke system.exit from any of your code, your main method or your unit integration test. This will mess up the unit test running, or the JUnit framework that runs the code, because the VM exits, right? It's really not what you want. So if you see process finished with exit code, then that means that you called system.exit and you really shouldn't. And that's what I have for testing. So bottom line, testing is important. So important that I require you to do it, and I validate that you've done it by measuring the code coverage of your tests. I hope you enjoy tests. Testing. I encourage you to test from development. I don't really have a way of measuring how much test driven you've done. However, one of the things that I've found is that if you do TDD, test coverage isn't a problem at all, right? Because you don't write any code, any source code, until you have a test for that. And if you're disciplined about only writing as much source code as it takes to make the test pass, sort of by definition, you've got 100% coverage, or you've got nearly everything covered. So anyway, some food for thought when it comes to how to approach your tests. So this is all about testing. The last handout is all about documenting. Okay. So, one of the things I think a lot about is communication in a professional context, and how we as professionals, especially software development professionals, are, obligated, professionally obligated to communicate about what we do. And as a matter of fact, there is a real almost tyranny of lack of documentation about what we do. It makes it really, so if there isn't a good explanation of what was done and why, it makes it very hard to work with software. If you don't communicate what you've done, people won't understand the value of what you did. So I have a couple of mechanisms that I leverage in the course to give you experience documenting your code and conveying in words what it is, what your code does. The first one is the plan of attack. So you might have noticed this on the assignments. So like the very first footnote, I don't know, I have a lot of footnotes. So like I say, project 1 here is worth 6 points, and if you go down to that footnote, which I guess isn't hyperlink these days, it says that 5 of those points are for the code and 1 is for the POA. POA is a plan of attack. So what is a plan of attack? Well, it's just simply an email that you send to me that contains a design document for your project. And basically, I want you to tell me what your project's going to do, and more importantly, how it's going to do it. Please just send me, a text email. I don't want a PDF attached or a Google Doc that I have to go click on. Nope. Please just send me a text in the body of an email. And it should be a couple of paragraphs. Don't send me code. The code is in GitHub. I can look at it if I want. But no, instead, describe in words how you'll implement your project. And this is worth 1 point of each project grade. You have to do one for the koans, but you have to do one for all of the airline projects. The POA is due 3 days before the project is due, so I think most projects are due on Wednesday, which means that it's due on Sunday. The POA is due on Sunday. And there aren't late POAs, just get it in by Sunday. And please mail it to me at whitlock@cs.pdx.edu with the letters POA in the subject. Oh yeah, and also the name of the project in the subject. I have filters in my mailbox that will put them into its own folder. That makes it easier for me to find it when I have to grade it. But please, this means that if you have like an important question for me or something that you want me to see, don't put POA in the subject. Put something else. And oh yeah, also again, I don't accept late POAs, so just please get it in. Even if you're might need a day or two, you're going to use a late day when you submit it. Please, don't be late with POAs. Now, there's a not so subtle goal for this is that by having this due on Sunday, 3 days before the project is due, it forces you to think about your project. So you can't wait until the last moment to start it. Actually, I found that that's a pretty good way of incentivizing people to at least get a start on their project, not the day before it's due. Because even though these projects might seem easy at the beginning, history shows that they're not. Right? Go back to the README for the getting started repository, and you'll see that it takes a number of hours, or at least most people, virtually everybody. It takes more than 12 hours to do even the simplest projects. So plan of attack is one method that we document our code and share what we do. Another one is Java.comments. comments. So there's documentation that you write about your software, and then there's documentation that you write in your software in the source code. And Java has a really nice facility for that called JavaDoc. And you can learn more about it here. But basically, and I'll show it to you in a minute. You have like these special comments that are that describe the program element, like the class or the method or the field that follow them. That have a special format that can be consumed by this tool called JavaDoc to create nice looking documentation like HTML or PDF or whatever. I'll just show it to you. So here in my airline project, if I run the Maven JavaDoc plugin, I say, Maven W JavaDoc::JavaDoc. What this will do is that it will, instead of, I guess it'll compile the code, but then it'll also generate API documentation. It'll warn about a bunch of things from that code. And we can open this in Target. Let's see, here is it JavaDocs, JavaDoc bundle options, part in site. Where are the, goes under reports. Yeah, reports, API docs, index.html. Here is the code. Here are the API docs that are generated for all the classes in the airline project. Here's like project 1. So I'm going to do like a back and forth between. Actually, project 1's a bad example. Let's do, well, it's probably the best example we've got now, isn't it? Because I don't have ones for airline and flight, because that's your job. So here's project 1, and, well, it has, oh, I know what I want. No, I wanted you to do this on student. Sorry, let me do it on student. That's probably a way better example. Because, yeah, the student class actually has, actually has the more interesting JavaDoc. Yeah, here's student. So I have so this describes the the student class, and it even links off to like the JavaDoc documentation, so you can find all about like here's what an array list is, right there, and this is the the documentation from Oracle. But it also has things like this class, oops, is represents a student. That is terrible grammar. I should go ahead and fix that. So if I go to the student class here, oops, you'll see the following. It has, before the declaration of the student class, it has this special little Javadoc comment that starts with, oops, yeah, that starts with slash star star and ends with star slash. This is a Javadoc comment. And the Javadoc utility parses the source code and finds these comments and then extracts them into Javadocs. So that then is translated into this text right here in this HTML page. And notice it does things like when you put code there, it makes it affixed with font, all that kind of good stuff. And it tells you about what fields are inherited, tells you about the constructor, and you can navigate down the constructor here. And the description of the constructor is it creates a new student. And again, that also comes from Javadoc code. Right, there it is, creates a new student. And you'll see that every parameter to the constructor is documented with an @param tag, and that describes each of those parameters. And then the Javadoc tool again extracts information from this comment in the code to generate descriptions like this. So the name, the classes, the GPA, and the gender. Again, all of this comes from the API documentation. So some of you might have been seeing this the other night, with the student class, or wondering, what's up with that formatting? Well, that's what this is doing. What this is using the standard Javadoc notation for describing this class and this constructor. And again, all the public methods down here, I put API documentation there so that as examples of how to write this stuff. This is in the student class. What you'll be doing in your project is something similar for the code that you write. So the airline class, the flight class, the project one class. So please have a Javadoc comment that describes the functionality of each class and each method within that class. Make good use of the @param, @return, and @throws tags. If you want to learn more about the Javadoc syntax and what's available, you can click on this link here. When I grade your projects, I'm going to use this special, another -p grader thing to do the following. So this will run a special, what's called a Javadoc doclet, that will extract the there you go. Extract this text representation of your Javadocs that can quickly scan to see, oh, hey, which classes have Javadoc documentation, and which methods don't. And then based on this, I will, or actually the graders will give you points towards your final grade. And so then it's another test case that's there for each project. And I reserve the right to deduct up to 1 point from any assignment that doesn't seem to be well documented. And it's really a judgment call on part of the grader. But the expectation is that anything that shows up in this -p grader Javadoc ought to have a comment on it. Oh, and just another note, when it comes to your code, I recommend that you follow the Java style guideline. However, I won't be assessing any of this. I don't look at your code as part of your grade, but hey, if you ask for some help, if you share a GitHub repository with me, I'll be able to approach your code more easily if it follows the style guideline here from Google. Okay, and finally, the last piece of documentation is all about the README. As you may recall, Project 1 has a -readme option. And what this does is that it prints, when -readme is present on the command line, it prints a brief, concise, and nicely formatted text description of what your project does to standard output. Please make sure that includes your name and which assignment you're talking about. And it should be more than just command line usage, right? So it's not just like, here's what the command line is. It should have a little description of what the project does, and this should change with every project. Note that when dash readme is specified, all your program should do is just print the readme. So it shouldn't do any error checking. It shouldn't, process anything about what's on the command line. Nope. As soon as your program sees dash readme, it should print the readme and exit. Now, when it comes to implementing the README, it's perfectly fine to hard code a bunch of text into your Java source code, especially for Project One. That'll work just fine. However, it's much easier to read that to author your README in a file. And over here in the resources directory, I have a file called readme.txt. It starts out with just a README file. And if you look in the test code for, I believe it's Project One test. Yeah, there's some code over here that shows how you can read the readme.txt file. It's something called a resource, and resources are described in the Java I/O lecture. You might want to take a look at those. Anyway, you can get a resource for this for the README, and then you can just print it out line by line. So I include this example in here so that you can copy it into your main method and invoke this code when the dash README is specified. If this seems like a little too much for Project One, that's absolutely fine. You can also implement your README as just hard-coded text inside the source code. It's not going to make any difference to me. Okay. Note though that that a resource file isn't exactly the same as a file on disk. I over the years, a number of students have have looked for a file called readme.txt on the file system, which might work while you're developing it, but when I run it and when I use the executable jar file, it will not work. So make sure that you're loading it as a resource. This code is meant to give you an opportunity to experiment with learn about the resource API early on, because every single one of your projects is going to have a README, and so then this is a good thing to and invest a little bit of time in Project One. What's complaining about here? Oh yeah, it doesn't have a parent. Little typos all over the place. Okay, and that's it for documentation. So let's see here. Where are we at? Those were the three things I wanted to cover in this screencast. I don't know how long it went. It was probably longer than I anticipated. But I wanted to, because this is all just one-way communication, I figured I'll just pre-record it and send it out to you. That'll just have more of a conversation, be more interactive in class tomorrow night. I do encourage you to read over each one of these PDFs yourself. And again, reach out to me on Slack if you've got any questions. That's everything I've got for now. Thanks for listening. I will see you in class tomorrow. Bye now.